and a link for that recording will be made available later on. Also on the call are additional resources from our development team who will be on standby to answer any questions you may have. So you'll notice within the GoToWebinar application, there is an option there to submit questions you may have. So as you submit questions, we'll do our best to answer those. And if there are any questions we can answer, we'll provide an update on those questions after the call in a follow-up email. My name is Randy Rafi. I'm the Director of Sales with Silac Software, and doing the technical presentation today will be Mike Sargent from our development team. Mike was instrumental in the development of MP Author, MP Author Professional, and in particular the support for authoring SNMP-based management packs. So you're speaking to the man later, and he will be showing you how to use those features in MP Author Professional. A little bit about Silac before we get started. We were founded in 2003, and we cover a wide variety of capabilities. Our solutions include compliance, monitoring and reporting, authoring of management packs and baselines, as well as reporting solutions for System Center and OMS. Products include the High Trust Compliance Pack for monitoring security compliance and reporting on those. MP Author is the free authoring application, and today we'll be using a new application needs to be added to this slide. That's MP Author Professional. MP Studio is the enterprise product, if you would. It includes all of Professional and all of MP Author. CP Studio is our tool for authoring configuration manager baselines. We also provide services in custom development for System Center, things like baselines, management packs if you want help with that, and other extensions to System Center, OMS, Power BI, and Azure. We've got well over 5,000 users of the MP Author product, so we've been collecting your feedback for some time now, and that's what has led us to developing the SNMP support and other advanced features in MP Studio, MP Author Professional, and in MP Author. So MP Author is a free tool, and it's designed to help IT professionals start developing management packs for internal applications, or perhaps vendors have supplied management packs and you need to be able to, vendors have not supplied management packs and you need to be able to monitor those with Operations Manager. MP Author, MP Author Professional, and MP Studio leverage the same wizard-driven designer that that you'll be seeing Mike use today, but it's designed to help you by pre-populating, say, names for rules and monitors, etc., and also pre-selecting the most common settings, or the settings that will most likely be the ones you'll need. You can also modify those as well. So with Author and the other authoring tools, you can create and configure discoveries, targets, rules, monitors, as well as vendor knowledge. Now, MP Author Professional contains all of MP Author, and then some. And this slide covers just the new things, the advanced authoring capabilities not available in the free version. So developing a new class, new SNMP target, new relationships, those are advanced authoring capabilities. And then there's the process monitor, roll-up monitors for aggregate and dependency, and then new in this release, SNMP 2-state, 2-probe, SNMP 2-state, and 2-trap. So Mike will be showing those today. In terms of rules, SNMP probe event and perf rules, SNMP trap-based event and alert rules. So we'll also get a look at those today as well. Again, it's wizard-driven, and you can create discoveries, targets, rules, and monitors now for both Windows and SNMP devices. We do have some special introductory pricing there. Perhaps I'll share my email address if you would like more information, but this is until the end of August, and you get the first year's annual maintenance at no charge as well. So sweet deal there. MP Studio, this is the product that offers more than just the advanced authoring. It includes MP Author Professional within MP Studio, so all those capabilities you get and then more. I won't be demonstrating MP Studio today, but could also set up a one-on-one call later if you want to see a demo. I'm happy to do that for you, and I'd show you some of the following features. Reporting and documentation capabilities, really sweet in MP Studio. You can automate that stuff and get some very rich detailed reporting that shows you, in fact, what overrides have been configured for the various elements. Speaking of overrides, MP Studio is up to 16 times faster than native tools when creating overrides. You can create overrides in bulk, for example, and literally create hundreds of overrides in less than a minute. It's got all the advanced authoring capabilities in it. It has version control capabilities, so you can create a backup for, just simple backup purposes, but you might also want to roll back to a previous version of an MP. And while you're doing that, it's a best practice. Always put management packs in the store database. If you make changes, you can schedule a nightly backup. All that information stored in the database allows us to seamlessly generate the audit history and help you identify who changed what and when. Okay, so very powerful auditing capabilities. You can also view the running workflows for a given agent, and we'll include the overrides and show you which elements they reference, so you can really see the effective configuration and what's running on a server. Last but not least, MP Studio supports pre-deployment testing. What we're doing there is simulating the management pack running against a server or servers on your network. We're collecting that real-time data, bringing it back to your laptop or desktop, comparing it to the configuration of the management pack so that we can show you the resultant set of alerts. And that's a simulation, but it's based on real data. You can do it with a file-based management pack, and in the end, there are no alerts generated in your environment. So this is an isolated test of the management pack. Okay, I want to leave as much time as I can for Mike to get into the technical goodies on authoring SNMP-based management packs. I'll just finish off slides by saying MP Studio, we have a special there at $19.95 per user, and you get the first year's annual maintenance at no charge. So that's a pretty sweet deal. That's $500 off the regular price, plus the savings of 20% because you don't have to pay for the first year's annual maintenance. Okay, now let's turn things over to Mike, and Mike will be doing our technical presentation. Over to you, Mike. You're still muted, just so you know.
Thank you, Randy.
My pleasure.
Quick rundown of what we're going to do this morning. Some of you may have been to the webcast where we did introducing version 7. You're going to see some familiar stuff here, but basically I'd like to go through all the wizards, and I'll be spending more time on them, so I'll be able to give a deeper description of what's going on. I'd also like to finish up with enough time at the end, so maybe about 10 minutes, so that if you have specific questions about how to do some of these operations, how to monitor specific things in your environment, we might be able to give you some help with that. So I'm hoping that'll work out well for us. So let's quickly go through this. With MP Author Professional and MP Studio 7.0, we now have the ability to create management packs that are specifically for SNMP devices. So let's just go through one of those. Now I'm going to give this a much better name. I'm going to save it to a file system in this case for this demonstration. Here we specify which references are to be added to the management pack when we create it. So I'm going to select SNMP for SCOM 2012 R2. We also support SP1 and just the regular 2012 release, the first release, the RTM release, if you want to. But we're just going to create an empty management pack with those references. So the first thing we want to do is discover our device. Now with Operations Manager, you have to register the device as the same way you register any Windows computer. And what that does is it creates a node class. And what we want to do is refine that so that we can target things rather than targeting every node in the system. So let's create our target. Target just being a class and the discovery of that class. Now I've reset everything here, so I've got nothing set up. So we'll just go through this. We have the ability to go out and connect to a device, read the available variables from it to make browsing-based authoring here, so you don't need to type anything. But I haven't got anything registered yet, so let's add a new device. So I'm going to add my local router here. I'm going to use SNMP version 2 to connect to it. So I'm going to type in the not exactly secret password here. If you're not familiar with SNMP community names, they're transmitted in the clear over the wire, so anyone on your network with Wireshark can see them, so we don't consider them a password. They really aren't. If you're using SNMP v3, the passphrases there, in fact, are much more secure, and we wouldn't show those. I've gone out to the device by clicking the Validate button. I've connected to the device, and I've fetched back information from the device, which is how it identifies itself. Now, this can usually be changed for SNMP devices, but that's what it's currently returning. What I'm going to do is I'm just going to replace that name with the actual model name. It's a Cisco RV180W router, and I'm going to save that device here. And we can create multiple devices here. I'll just create a second one. And let's just hope this works. A little problem with my VPN this morning. I think it's working now. This goes across the network to try and connect to a different router. And that looks like maybe it isn't working right now. This is probably going to time out.
Mike, your IP address is wrong?
That would do it. Thank you, Paul. Okay, unfortunately we have to wait for this to time out. In the meantime, as I said, you can create multiple devices, and normally once you've created them once, they appear in this Save Network Device list on the left, and you'd simply select them. So this should finish its timeout. We actually reduced the timeout for this particular operation, but we still try and retry because SNMP uses UDP, and so it's not a guaranteed transmission. So things can get lost, so we have a lot of retry logic in here to make things reliable. Unfortunately, it means when you've actually typed the wrong IP address, it takes almost a minute for us to finally decide that it's not going to happen. On the other hand, if the device is slow, you do want that time, so it's sort of a lose-lose situation. So if we type in the right IP address and hit validate, there, that's how quickly it can come back. So there's our second device here. So this is my local router, this is a router in the office, a firewall in the office. For the time being, I'm just going to use my local device so we don't have to worry about the firewall. All of our wizards typically start with a page like this where you can specify a computer or device that we're going to browse to get information from. You can also select manual. Now with manual, you have to do a lot of typing and you need to know an awful lot of stuff. You'd only do that as a last resort if you simply cannot get access to either the device or computer you're interested in or a similar one. I'm not going to follow up on that. Here we have the ability to browse the device to find out what's available on it. So let's go and do that. Now we've gone off to the device. We were asking it for all of the variables it can return. And you can see that list here at the top. And we've got three columns here. The OID is what is actually returned from the device. So this second one, 136.121.12.0, is what's look up and try to translate these into standard names. And so, for instance, that is System Object ID defined in the SNMP v2 MIB. I'll discuss that a little bit more, but I'm going to dismiss this warning here. there were a bunch of things that it didn't know how to interpret. So we have these addresses, these ones that have the 8072 in them. And so these OIDs came back with a value, but we don't know what it means. The MIB files are management information blocks. These are text files provided by both standards groups and vendors, which identify all of the variables and the capabilities, the traps, everything about a device, so that we can do these sorts of translations and understand it. Now, we know the two enterprises that were missing from that list, so 2021, which is from UC Davis, and 8072, which is net SNMP. We have this Manage MIBs dialog where we can add and update. We have control over things. We can rename things. Let's just simplify this down to UC Davis. This button here, Add Update MIBs, is what allows us to add MIBs into the store. Now, I've already gone out and gotten these MIBs. And when we add them, they are compiled in, they're copied, compiled, added to an index file. You may not have all the MIBs you need. And as just a general good piece of advice, try to get vendor-specific MIBs from the vendor themselves. Some are very good and have them put up on public sites that you can get into very easily and get them from from a respected authority, so you know what you're getting. Others require you to create logins and enter serial numbers for the device and horrible stuff like that, and they're a real pain in the butt. But if possible, try to get your MIBs from the vendors because you know you're getting the most up-to-date and you're getting them from a reliable source. Having said that, we have a link down here to OID View. Now, OID View has a button here to download MIBs, and they have, close to 7,700 MIBs online. You can search by vendor name and apparently I selected one. Enterprise number, so that 2021 will be down there somewhere, which is actually where I may have gotten these ones. 2021 UC Davis, that sort of stuff. I have no reason to suspect there's any reason not to choose MIBs from OID View. It's just generally you should try to get them from the most authoritative first-party source if you can. We'll just add the remaining MIBs from a net SNMP here. And at this point, we've added them all in and we have an index. So when I close this, we go back and we requery the device. Because we had unknown OIDs, we go back, get the list again, and now we know how to interpret them all. So if we look down here, now we actually know what they mean. And when we click on a particular variable, we have a description here. This is a description that came from the MIB file. We can tell the access, whether it's current or deprecated. Parent, some other information will show up here if possible. Something I haven't shown before is this LookUp button, which uses the OID and looks it up on OID info and can give you a lot of information on it there as well. I think that's probably a pretty good place to leave that discussion. When we're discovering a device, this system object ID is almost always the thing we use. This is an object ID, an OID, that was registered specifically to Cisco. So enterprises is the highest level. Then we got .9. 9 is the registered enterprise number for Cisco, and they're allowed to create any tree below that they want. So this 6.1.23.1.111.1.1 represents this router, this RV180, or at least the family. There's a number of things like the W is a wireless. There's an RV180 without wireless. There's a family that may be represented by that same OID, or this may be an individual OID for that specific model. I don't know the difference, but generally it doesn't seem to matter for me. So we'll add this. We can add other variables here that we'll use to determine if this is the correct device to discover. I'm not going to do that, but we will show how this would be done a little later for other things. We can also add additional properties to the class. So when we do our discovery, we can get additional variables from the device and add them in as properties to the class. So just for this example, I'm going to include this one, IF number, which is the number of interfaces in the device. And we also allow you to filter here. So we can search for, let's search for, if I spell it right, forward. This is a forwarding flag, which basically says something's capable of acting as a router. I'll just add those two as an example here, but you can add anything you want. This next panel allows you to specify the target properties. We could change the name of the property if we wish to. We could also change the type, whether it's a key, and if it's a string, whether it's case sensitive, min, max, lat, those sorts of things. Generally, wouldn't need to change them. One nice thing is we get a really good description from the MIB file for this. Now here's where we identify the class that will be discovered, the target. Now, as I mentioned, SNMP devices don't have a really good place to get a specific name that's consistent that we could use. So I'm actually going to have to type it in here. So we'll just call this RV180W. We automatically create a display name, which is a simplified version of the name. The base class, well, this is a router. So let's actually choose router as the base class here. And there it is. This is the name of the discovery, which is basically the same as the name of the class, just with discovery tacked on the end of it. You can change it if you want to. Probably won't need to in most cases. And here's our target. Now, for a device that you're discovering, node will almost always be the target that you want to use. So that's what we've chosen as a default. I'm not going to change it here. And here's the expression we're going to use to match. Now, in this case, we want our system object ID to be equal to that particular value, and that was the value we got back from the device, so we know this is very reliable. If we'd specified other variables, we could have, they would all be in here as ands, and we could edit them and change whether they're equal or not equal in values and that sort of thing. We'll discuss the expression pane in more detail when we look at some of the other things. But for the time being, for discovery, it's almost always going to be object ID equals what you queried. Discoveries are typically run once a day, so that's fine, but you could, of course, could change that. And then all of our wizards end up with a summary page here where we describe what it is we're going to do. And, you know, so there's the name, the display name, the description, what the base class is, the properties that we're going to add, information about the discovery itself, you know, it's enabled, the name, description, what the target is, how often it will be run, and in this case the expression, what it is we're looking for, that system object ID value is equal to this. Click Finish, and just like that, we have our target and our discovery created. You remember the properties that we defined, they're in there. And something that we haven't perhaps made enough mention of in the past is that this properties edit view over here, you can change anything that's in black here. You can't change the stuff that's shown in gray. So here we can't change the base class, but we can change the accessibility. So from public to internal and back, we could change the display name, the description, or the name here. Other elements, for instance, let's look at the discovery. There should be more to change here. Well, there isn't in this case. You know, whether it's enabled, the priority, some of these other things. But that's a good place to do it rather than having to go in and change the XML for some things. Now, I'm just going to take a sip here. Once we've created our device, let's create a monitor. So we're going to look at the two-state 2 probe monitor. Now, a probe versus a trap. Probe is when Operations Manager actively goes out to the device, asks for particular variables, and acts upon them. A trap is when the device informs Operations Manager of something, and Operations Manager responds to that. So probe is typically done to look at things periodically. Trap is to handle those exceptional cases, and we'll get into that in detail. So let's create a probe monitor. Again, here's the device we can use. We have 2 probes and 2 traps for the trap 1. We'll go out and query our device, and in this case I want to look at the CPU idle. So we'll add that. This is the percentage of processor time spent idle over the last minute. I can specify a second probe variable here, but if I don't specify it, we'll reuse the one that was specified for the first one. And what I'm going to look for in this case is I want to raise an alert if the idle percentage gets too low, i.e. the device is pretty busy. So the second probe variable would bring it back to the health state. We'll use the same variable, we don't need to specify it. Again, we get to target our device, which is fine. The name is pretty good here. You know, we've got the CPU idle performance probe monitor in here. You can change those if you want to. How often we need to run it? I don't think 2 minutes is probably what we need here, so let's look at perhaps 15 minutes. Here we see this expression builder again. Now, in this case, we've said, you know, CPU idle equals the current value. We don't really want that. What we want is the idle should be greater than or equal to, let's say, 50%. And so we see the expression as, you know, CPU idle value greater than or equal to 50%. The next will be the other expression for the other state, where we take the logical complement of that, so CPU idle less than 50%. You can, of course, change them if you want to. They don't need to be the same, but typically one is going to set something, one is going to handle one state and the other will handle the complement of that state. So here's our monitoring conditions. If the CPU idle value is greater than or equal to 50, our health state should be success, which is good. And if the CPU idle value is less than 50, our health state would be warning, or we could make it an error. I'm going to leave those alone. We'll come to our alert. We want to generate an alert if we go into a warning state. We want to automatically resolve the alert when the monitor returns to a healthy state. We have a name and a display name for that alert. We can play with those if we want, priority and severity. And we have the description down here. And this is a case where I want to get into it a little bit more detail just to give you an example of some of the things you can do. This is a text field with certain replaceable parameters in it. And that's these things that show up in $signs. So let's create our own description here. CPU on device, and we'll choose from the target the display name of the device with IP address, and again from the target we can get the IP address here, which is, well, you'd think I would have looked this up before, right? Must be there somewhere. All right, we can get that from this, which is the source IP address. Is currently running with only, and we'll put in the data for the current value of the idle time. It should be more than 50% free. And actually I'll put a % sign here after that so that it looks pretty if we showed it. Next, and there's our summary of what we're going to do, the name of the monitor, the target, the parent monitor, this is performance state here, what we're going to collect the data for, the expression and what the health state is, the second probe, the second expression, less than 50 in our health state of warning, how often we're going to run, and then our alert settings. If it's warning, we'll automatically resolve, name, display name, and the description. And there's our monitor. And I hope one of the things you're noticing out of this is how little typing I have to do to create these things. You know, I've created the discovery, the class, I've created a monitor, and apart from basically the name of the class and, you know, playing around with the description there, I haven't needed to touch the keyboard. Now let's take a look at the trap monitor. Now this is a case where the device is informing operations manager of something. So I'm going to look at the traps that seem to be available on this device. This list is not completely authoritative. We have to guess a bit here. But one of the ones we want to look at here is link down. This trap will be raised every time an interface basically changes state, goes down. So we'll add that, and I'm going to add for the second trap the link up trap. So when a link goes down, we're going to be notified, and that comes in as the first trap. And when the link goes back up, we come back in as the second trap. We're pointing to our device again, that's fine. Let's call that availability this time. We have a pretty good name, although you can change it if you want to. That trap will come in for any for any interface going down. Let's imagine the case where we have a branch office with a VPN connection that has to be up between the two of them. So in this case, although we're getting all of the traps, the only ones we really care about are for the particular interface with that VPN connection. The trap returns these top 5 values. So there's the uptime of the device, which is generally not going to be of much use to us. The trapoid, we could filter on that, but we only are selecting input from one trap, so that shouldn't matter. The index is which interface has changed state, in this case gone down, and there's an administrative status and an operational status here. So let's look at the index of the thing equal to 5. 5 I happen to know is my VPN connection, so we'll just do that. So our case is we want a trap down where the interface is number 5. The second expression, this is the trap up, is going to be the same expression because we want to go back to a healthy state when link 5 goes up. So here's our health state. Now in this case, the first monitor expression was for the link down where interface 5. Oh, we don't want that to be healthy, we want that to be an error because the link's down. So we've automatically changed the second health state to success. This is the case where the link goes back up. We can generate an alert for that. So when we go to error state, we can fill in information here, but you've seen how we do that, so I'm not going to spend much time on that. Again, our summary here, our link down trap for index 5 brings us into an error health state. The second trap, link up for index 5, is a success state. We'll generate the alerts, and we're done. And so Stephen Morrison's asked, does this read in the traps available from the MIB? Unfortunately, well, yes and no. We unfortunately have to intuit it. There's no definitive statement about which traps a device will return. So we look at the enterprises and we report to you the list of all the traps for the enterprises that appear in the variables. So it's not perfect, but we believe it's pretty good. If you ever have a better idea on how to do this, please let us know, but if it's sufficient, then that should do it. On the traps, does it read in the variables that the trap contained, help build the description? Yes, once we've decided which traps to present to you, those list the variables that come in, and we do show them in the description field, and of course they show up in the list for the expression builder. Hope that answers that. I'm doing okay for time, so let's go through our rules. Probe event rule is where we want to look periodically, see the current state of the device, and we're going to generate events that go into the operational database and or the data warehouse. Again, we go out and look at our devices here, get all the variables. As an example, I am going to use that operational state of link 5. We'll add that. We can add more if we want to. I'm just going to stick with one here. This is the information that will go into the event. Most of it's defaults, but of course you can change it if you want, event numbers, categories, event levels. The description we fill in so that it makes a little bit more sense to you what that means. The checkbox here to add the event to the data warehouse allows you to decide whether it should go in the data warehouse or just the operational database. Again, we're targeting our device. We have a name here. You can change it if need be. How often we're going to probe the device. And then our summary. I think you've seen most of that, so we'll just do a finish on that. And I'll just show you, this is the events from Operations Manager. These were created with rules created with that wizard, but not this specific rule because it takes several minutes to come out here. But there's in particular an intrusion detection event, which is just refreshed. Gives you an idea of the information. These are all the variables that came in from that particular, this in fact from a trap. You can view the event data here and see the raw data if you need to. So that's the sort of thing you can get with the events. We also have performance rules, and we'll just demonstrate that fairly quickly. Again, we go out and browse the device. I think I'll look at that CPU usage or CPU idle here. Let's just see what we've got here. CPU, we have user time and system time. So let's just look at user time. Unfortunately, as with all the performance counters, there's really only one variable you can specify. There's some identification of it. So, we filled in the name for the counter name. You have, again, your choice to add it to the data warehouse, our target, the name, how often we're going to schedule that. And we're done there. And here's an example of, again, a similar rule created with MP Author Pro, where we're looking at two things here. The ICOMP ping response was in fact automatically done by Operations Manager when the device was registered. And that's the one that shows up in green. The second counter here is for CPU utilization on our sonic wall, and that was created with a performance collection rule with MP Author Professional. And the last rule we can create here is a trap event/alert rule. So again, we go out here and we look at our traps. Is there any document on how to do this for when we want to do this for ourselves later? Karen, the webcast is being recorded, and that'll be provided to you. And hopefully there'll be some other information. I'm not sure what else we can give you, but when we go to the Q&A at the end, maybe we can give you some more information on that. Just getting back to Stephen's question about the variables. So we know that for this authentication failure, I happen to know that one doesn't give anything useful. Entity configuration change. Does this have variables? No. Actually, let me just go out. I'm going to change the device here. I could have done it from the other window. We'll go out to the sonic wall because it actually has much better trap information. Unfortunately, it's going to be a bit slower because it's got to go across, and we don't have everything filled in here. So we need to do 8741. We'll quickly do that. Let's get added. Close here. We go and requery to find out what traps we now have. So here we have a whole bunch of sonic wall traps. One I'm going to use that I've used in many times before because it comes in frequently is this intrusion detection trap. And this is one that's raised every time this device rejects a request, and they come in all the time. If you're not aware, your system is under constant attack. Down here we have the list of variables that come in. So we have a trap info type, description, source IP address, and port, additional information like that. So we'll just choose that one for our example here. Again, we have the ability to create the event for it. We can choose whether it goes in the data warehouse or not, or we can choose that we don't want it in the operational database at all, in which case you'll note the rule category changed to alert, because if we don't add it to the database, then we have to generate an alert. This is something I haven't touched on before, this ignore the SNMP version number in traps. there are devices out there that, although they're SNMP version 2 devices, they return traps as version 1, and I'm guessing some V3 devices may return V1 or V2 traps. And if you are looking for a V2 trap for a V2 device and it returns a V1 trap, Operations Manager ignores it. We can tell you to ignore the version, in which case they'll always come in, and that seems to be a pretty good default. Again, our device, we have the ability to create expressions here. So here we have, and I'll just go down to here, those are all the variables above this highlighted one that came in. So for instance, we could say we want to know whether the source IP address is coming in as 10.195.27.92, which is a device here in my lab. It's a VM, which does come in and generate messages. And let's just say does not equal, because we want to ignore those. And so in this case, we would have this particular device we know will generate these traps that we don't want to hear about, so we want to generate traps for everything else. We can do a lot more here with ands and ors and multiple things underneath each and we can insert additional expressions to say that, well, for instance, the system uptime in ticks, let's say it has to be greater than 1,000, which means the device has been running for 10 seconds, because there may be some startup ones we want to ignore. There are things we can do like that. Our identification, whether we want to generate the alert, so we do. Here we can, of course, fill in all these values, so we can know what the source IP address was and all the rest of the variables that came in, the OIDs. We have the information that always comes in, you know, community string, version code, the event information that we defined earlier, the event ID, for instance. All those sorts of things can be filled in. For rules, we also allow event alert suppression, which by default we suppress on the device key, so only one alert would be raised. You can add more if you want. You can also put in custom fields, and again, we can fill in data from, you know, the destination IP address here if we wanted to. Our summary, and there's our rule created. And just a quick check here, this will produce a couple of warnings about a class or two. That's standard for the verify command, and of course we have the best practices analyzer, which will take just a little longer to grind through. And I'm just going to tell it to ignore all the past stuff, and then when we look down here, we'll see that we haven't got knowledge articles for the things we've added. We wouldn't want to do that. And it tells us incorrectly that we haven't got names and descriptions for these alerts. We do. They're there. This is actually a bug in the best practices analyzer. Other than that, we're clean, so that's pretty good. So that pretty much comes to the end of the stuff I wanted to demonstrate to you. And I think this would be a good opportunity to open up to questions from the floor and see if we can help you with what you want. So I guess the best way to do it would be post something in the questions section there, and I'll do my best to answer them. Paul, I think you've been monitoring these. Are there any open questions that need to be addressed immediately?
Should be fine now. I think, Stephen, you've had all your answers. Do you want to, we could also unmute individuals if somebody wanted to just basically put their hand up.